All right, so you're looking to really get into pragmatic programming,
Yeah.
like how to use it every day when you're coding.
Right.
Well, we've got this deep dive for you using the Pragmatic Programmer 20th Anniversary Edition.
Uh-huh.
It's a classic, but it's been updated, so it's perfect for the modern developer.
It has a ton of practical advice.
Yeah.
And it starts by talking about something I think we all struggle with.
Okay, what's that?
Trying to make things perfect.
Oh, yeah, aiming for perfection.
And this book just comes right out and says it.
Good.
Perfect software.
Yeah.
It just doesn't exist.
So then what do we do?
We just admit that we can't be perfect.
Okay.
And instead, we focus on making really good software
Reliable.
robust, even though it won't be perfect.
I see.
It's kind of like when you're driving defensively.
What do you mean?
You know you're on the road, and you know other drivers are going to make mistakes.
Uh-huh.
So you drive carefully so you don't get into an accident.
Oh, so it's like we're coding defensively.
Good.
We're assuming there are going to be problems, and we're writing code to make sure those problems don't cause too much damage.
Right.
Okay, I like that analogy.
So one of the best ways to do this is to use something called design by contract.
Okay, I've heard of DBC,
Yeah.
but to be honest, it always sounded a little scary to me,
Really?
like something that only really big companies would use.
I can see that.
Is it really useful for everyday coding?
Oh, yeah, it definitely can be.
Okay,
So with DBC, you're basically writing a contract.
a contract.
Yeah, but for your code.
What do you mean?
Well, you define exactly what each piece of code is supposed to do.
Okay.
Like what inputs it needs and what outputs it creates.
So you set up these clear boundaries.
Exactly.
So DBC is less about being super formal and more about being clear and setting expectations.
That's a great way to put it.
But how do we actually do that?
Well, the book talks about these things called preconditions, post-conditions, and invariants.
Okay, I'm not really familiar with those.
So to make it easier to understand, let's think about an example from the book.
Okay.
So they use the example of a function that handles deposits at a bank.
Oh, real world example.
Yeah.
That might help me get it.
So imagine you have a function that's adding money to an account.
Okay.
A precondition for that function might be that the amount you want to deposit has to be positive.
Oh, yeah, that makes sense.
You wouldn't want someone to be able to deposit negative money.
Right.
And then a postcondition could be that after you make the deposit,
Uh-huh.
the transaction gets logged in the account's history.
I see.
And then an invariant might be that no matter what,
Yeah.
the account balance never goes below zero.
Even if there's some kind of problem.
Even during calculations, yeah.
Wow. So you're basically baking these assumptions into the code itself.
Yeah, you're making sure those assumptions are always true.
That's really interesting.
And some programming languages actually let you do this.
Like build DBC right into the language.
Uh-huh. The book talks about how you can do it in Clojure and in Elixir.
So it's not just a theoretical idea.
Yeah.
It can actually be used when writing code.
Right.
And even if my programming language doesn't support DBC, I can still use those ideas.
Yeah, you can use them when you're designing your code and when you're writing documentation.
Okay, so this next concept was kind of a surprise to me.
Oh, what's that?
The book says we should try to make our code crash.
Crash.
Yeah, it even uses the phrase crash early, crash often.
Hmm.
Doesn't that seem kind of strange?
It does sound a little counterintuitive.
Like, why would we want our code to crash?
Well, think of it this way.
Okay.
Sometimes it's better to let your code crash on purpose,
Huh.
because that can actually prevent a worse problem from happening later.
Oh, so we're not talking about adding bugs to our code,
No, not at all.
but we're designing our systems so that if there is a problem,
Yeah,
they fail gracefully
right.
instead of causing a huge mess.
You want to make sure the problem is contained.
And that way you can learn from it.
Exactly.
Make your code stronger.
Yes. And the book talks about how languages like Erlang and Elixir are really good at this.
I've heard that those languages are built to handle failures.
Yeah, they
What makes them different?
Well, they have this thing called supervisors.
Supervisors.
Yeah. And they're basically like managers.
Ooh.
They watch over the different parts of your code. And if one part crashes,
Uh-huh.
the supervisor can restart it. And that can often fix the problem.
So in those languages, crashing isn't always a bad thing.
Right. It's more like a signal that something needs to be fixed.
That's amazing.
And it means you can build systems that can fix themselves
Oh, wow.
and adapt to all kinds of problems.
Okay, so now I want to talk about assertive programming. The book is really into that idea.
It is.
So I think we've all done this at some point.
What's that?
We're writing code and we think, oh, this could never happen.
Yeah, we make assumptions.
And assertive programming is about challenging those assumptions.
Right.
But how do we do that?
Well, instead of just hoping that your assumptions are true, you write code to check them.
Oh, so you're basically saying, I think this is true, but I'm going to double check just to be sure.
That's a good way to think about it.
And what kinds of things are we checking?
Well, you can use assertions to make sure that values aren't null,
Okay.
to check that your data is correct,
Uh-huh.
and even to make sure that your algorithms are giving you the right answers.
So it's like setting up alarms all over your code.
I like that analogy.
So if something unexpected happens, the alarm goes off,
Exactly.
and you know right away that something is wrong.
And you can fix it before it becomes a bigger problem.
But what about when our code is running in production?
Yeah.
Should we turn those assertions off?
Unless there's a really good reason not to,
Okay.
you should leave them on.
Why is that?
Well, the book has this story about a startup that used assertions in production,
Okay.
and it actually really helped them. Well, because of the assertions, they were able to find problems that they didn't even know existed.
Problems that they didn't catch during testing.
Right.
And because they found the problems early,
Yeah.
they were able to fix them quickly.
And that made their product really reliable.
Oh, so they were able to make a better product because they used assertions.
Exactly.
All right, now how about resource management?
Yeah.
The book says, finish what you start.
Right.
What does that mean in terms of code?
Well, if your code uses a resource, like it opens a file or
Okay.
it connects to a network,
Mm-hmm.
then it should also be responsible for cleaning up that resource when it's finished.
So it's not just about doing the work.
Right.
It's also about making sure that everything is cleaned up afterwards.
Exactly.
So the book uses an example of a Ruby program
Uh-huh.
that reads and updates a file.
Okay.
And the first version of the code forgets to close the file when it's done.
Oh, that's a classic mistake.
What's the problem with that?
Well, if you don't close the file, it can cause all sorts of problems.
Like what?
The file might get corrupted,
Mm.
or your program might slow down,
I see.
or it might even crash.
And the
The
solution?
book shows how to fix the code
Okay.
by making sure that the file is always closed properly.
So it's about taking responsibility for the resources that your code uses.
Right.
And the book also talks about these things called scoped resource management techniques.
Yeah.
What are those?
Well, those are features in some programming languages
Uh-huh.
that can help you manage resources automatically.
Oh, so you don't have to remember to close files and things like that.
Exactly.
What's an example of that?
Well, Ruby has this thing called blocks,
Okay.
and you can put your code inside a block,
Uh,
and Ruby will automatically close any files that you open inside the block,
even if there's an error.
even if there's an error. Yeah.
Oh, that's really helpful.
It makes your code much safer.
And it takes some of the work off of the developer.
Exactly.
Okay. I'm really starting to see how these pragmatic programming principles can make my code better.
They really can.
It's not just about making code that works.
Right.
It's about making code that's well-designed
Uh-huh.
and reliable.
Yeah.
And that can be changed easily.
Adaptable.
And that leads us to another principle from the book.
Which one is that?
Don't outrun your headlights.
Oh, that's a good one.
What does that even mean?
Well, imagine you're driving a car at night
Okay.
and you're going really fast,
Uh-huh.
but your headlights can only see so far ahead.
So you can't see what's coming.
Right. And if you're going too fast,
Yeah.
you might not be able to stop in time if there's something in the road.
Oh, I see. So this is about planning for the future,
It is.
but not trying to plan too far ahead
Exactly.
because you can't see that far into the future.
Right.
So how does this apply to software development?
Well, sometimes we try to predict what's going to happen in the future
Like what users will want.
or what new technologies will be invented.
And then we try to write code that will work in those future situations.
And the book is saying that's not always a good idea
Why not?
because we can't really know what the future holds.
So we should focus on making our code adaptable
Exactly.
so that it can be changed easily to
Yeah.
deal with whatever comes up.
And the book talks about these things called black swan events.
Black swan events.
Yeah, those are events that are totally unexpected,
Yeah.
but they have a huge impact.
So like a global pandemic
That's a good example.
or a war.
Or a major technological breakthrough.
And the book is saying that it's impossible to predict these events.
Right.
So there's no point in trying to write code that will handle them.
And they give an example from the early days of computers.
Okay.
Back then, there was this big debate about which graphical user interface would become the standard.
Oh, yeah. I remember that.
Some people thought it would be Motif,
Uh,
and other people thought it would be OpenLook.
and they spent a lot of time and energy arguing about it.
They did.
And then what happens?
Well, then the World Wide Web came along,
Oh, right.
and suddenly the whole debate didn't matter anymore.
Because everyone started using web browsers.
Exactly.
So the lesson is,
Don't try to predict the future,
because you can't.
and instead focus on making your code flexible and adaptable.
Okay, that's a good place to stop for.
All right.
We've covered a lot of ground already.
We have.
From accepting that perfect software doesn't exist
Uh-huh.
to embracing the idea of crashing early and often.
Right.
What are some of the key takeaways you want our listeners to remember?
Well, I think the main idea is that pragmatic programming is all about being adaptable and resilient.
Okay.
And it's about questioning your assumptions.
So it's not just about writing code that works.
No?
It's about writing code that can handle the unexpected.
That's right.
And that could be changed easily when things change.
Exactly.
And these principles are just as important today as they were 20 years ago.
Maybe even more important.
All right, so let's take a short break. And when we come back, we'll dive into some of the more specific techniques and examples from the pragmatic programmer.
Sounds good. Welcome back. So we were talking about not trying to predict the future.
Right. Don't outrun your headlights.
Exactly. And that leads to another idea from the book.
Okay, what's that?
The idea of taking small steps.
Oh, yeah. Take small steps. Always.
That's the one.
It seems pretty simple, though.
It is simple.
But I guess sometimes the simplest things are the best.
Yeah, it's all about breaking down big problems into smaller ones.
Okay.
And then you can get feedback more often.
And make changes if you need to.
Exactly. Like if you're driving on a winding road at night,
You're sticking with the driving analogies.
you don't want to go too fast
Why not?
because you can't see very far ahead. So you
Ah.
have to go slow enough that you can stop if you need to.
So in software development, what's the equivalent of going slow?
Well, it's about getting feedback as often as possible.
Okay.
So you might run your code in REPL,
Uh-huh.
or you might write some unit tests
Or you might even talk to a user.
and get their feedback.
So it's not just about writing code quickly.
Right.
It's about taking the time to reflect and make sure you're on the right track.
Exactly.
Okay, that makes sense.
And speaking of getting feedback,
Yeah?
we should talk about refactoring.
Oh, yeah, refactoring.
It's one of my favorite topics.
What is it?
Well, it's the process of improving your code without changing what it does.
So you're not adding new features.
No, you're just making the code better.
But how do you make code better if you're not changing what it does?
Well, you can make it more readable, or
Okay.
more maintainable,
Uh-huh.
or more resilient.
Resilient.
Yeah, that means it's less likely to break.
Okay.
I like how the book describes it.
How's that?
They say it's like cleaning up the kitchen while you're cooking.
Oh, that's a good analogy.
So you're still making dinner,
Yeah.
but you're also making sure that the kitchen is clean.
So you're making the code base better without changing the recipe.
Mm.
But it's not just about making the code look pretty.
No, it's much more than that.
What else is there?
Well, refactoring can help you eliminate duplicate code,
Okay.
and it can make your code more modular.
Modular.
That means it's broken down into smaller pieces,
Mm-hmm.
which makes it easier to understand and change,
And refactoring can also make your code more adaptable.
so that it's easier to change in the future.
And the pragmatic programmer has a lot of different refactoring techniques.
It does.
It's not just one thing.
No, it's a whole toolbox.
What are some of those techniques?
Well, some of them are pretty simple, like renaming variables and methods.
Okay.
And others are more complex, like extracting functions and classes.
So there's a technique for every situation
And the key is to apply these techniques gradually.
in small steps.
That's right. And you don't want to make big changes all at once,
Why not?
because that's risky.
Oh, so it's better to make small changes over time.
Exactly. It's like the idea of taking small steps.
Right.
You're less likely to introduce bugs if you make small changes.
So it's not about finding the perfect design up front.
No.
It's about continuously improving the code.
Like a gardener tending their plants.
Okay, so how about testing?
Testing is super important.
The book talks a lot about that.
It does. It says that you should write your tests before you write your code.
Oh, yeah. Test-driven development.
TDD.
I've heard of that.
It's a really powerful way to write better code.
How so?
Well, when you write your tests first,
Uh-huh.
you have to think about how your code is going to be used.
Before you even write it.
Exactly.
Right.
It forces you to think about the design of your code,
And it makes sure that your code is testable.
which is really important,
And TDD isn't just about unit tests.
right? No, it's not.
What other types of testing are there?
Well, there are integration tests
Okay.
and system tests
Mm-hmm.
and even property-based testing.
Property-based testing.
That's a really cool one.
Or what is it?
Well, instead of writing specific test cases,
Like testing for specific inputs and outputs.
right, you define properties that your code should have.
Properties.
Yeah, like this function should always return a positive number,
Okay.
and then the testing framework generates random inputs.
And sees if the code still satisfies those properties.
Exactly. It's a great way to find bugs that you might not have thought of.
So it's like having 1,000 testers all trying to break your code.
That's a good way to think about it.
Okay, so how about security?
Security is really important too.
The book talks about that as well.
It does. It says that you should think about security from the very beginning.
So not just when you're finished writing the code,
Right. You should think about it during the design phase
then during development.
and even during deployment.
So it's not just about reacting to threats.
No.
It's about preventing them in the first place.
Exactly. And it's not just about protecting against hackers.
What else is there?
Well, you also need to think about data privacy
Okay.
and responsible error handling.
So you need to make sure that you're not accidentally leaking sensitive information
Right.
and that you're handling errors in a way that doesn't make the problem worse.
Exactly. It's about being a good steward of the data and systems that you're responsible for.
Okay, so now let's talk about concurrency.
Oh boy.
I know that concurrency can be a really tough topic.
It can be.
What advice does the book have for us?
Well, it says that the key is to break temporal coupling.
Break temporal coupling.
That's a mouthful.
What does it even mean?
It means that you should avoid writing code that depends on the order in which things happen.
Okay.
So for example, if you have two threads that are both trying to access the same data,
Yeah.
you don't want the outcome to depend on which thread gets there first.
Because that could be unpredictable.
Right.
So how do we break temporal coupling?
Well, the book talks about a few different techniques.
Like what?
Well, you can use message queues
Okay.
or actors
Uh-huh.
or even blackboards.
Blackboard.
Yeah, it's a way for different parts of your code to communicate with each other.
Without having to worry about the order in which things happen.
Exactly.
So it's about making your code more flexible.
And more resilient.
Okay, I see.
And another important tip is to avoid shared state.
Shared state.
Yeah, that's when multiple threads are all trying to access the same data.
And that can cause problems.
You can get race conditions.
Ice conditions.
Yeah, that's when two threads try to change the same data at the same time.
And it can lead to unpredictable results.
Right. And you can also get deadlocks.
Deadlocks.
That's when two threads are each waiting for the other one to do something.
And they end up stuck.
Exactly.
So how do we avoid these problems?
Well, the book talks about a few different approaches.
Like what?
Well, you can use immutability.
Immutability.
That means that your data can't be changed once it's created.
Okay.
And you can use message passing.
Uh-huh.
That's a way for threads to communicate with each other without sharing data.
And you can also use transactional memory.
That's a way to make sure that changes to data are atomic.
Atomic.
That means they either happen all at once or they don't happen at all.
So there's no chance of two threads getting halfway through a change and then interfering with each other.
Exactly.
Okay, so we've talked about a lot of different topics in this section.
We have.
From refactoring and testing
Uh-huh.
to security and concurrency.
Right.
It seems like the pragmatic programmer really does cover everything.
It does.
And even though it was written over 20 years ago,
Yeah,
the advice is still relevant today.
it is.
Okay, so let's move on to the last part of our deep dive
Right.
and see what other gems we can find in the rest of the book.
Sounds good.
All right, so we're back and ready for the last part of our deep dive into the pragmatic programmer.
Yep. Sounds good.
We're talking about concurrency
Mm-hmm.
and how to make sure that our code can handle multiple things happening at the same time.
Right. Concurrency can be tricky.
It can.
But the book gives us some good advice.
Like what?
Well, it says that one of the best things you can do
Mm-hmm.
is to minimize shared state.
Shared state. That's when multiple parts of your code are all trying to access the same data at the same time, right?
Exactly. And that can lead to all sorts of problems.
Yeah, like race conditions and deadlocks.
So the book suggests a few different ways to avoid shared state.
Okay, like what?
Well, one way is to use immutable data.
Immutable data.
That means that the data can't be changed once it's created.
Oh, okay.
So if you need to update the data, you have to create a new copy.
And that way there's no chance of two parts of your code trying to change the same data at the same time.
Exactly.
Another way to avoid shared state is to use message passing.
Right. So instead of having different parts of your code directly access the same data,
Huh.
they send messages to each other.
Oh, okay.
And that way the data is only ever accessed by one part of the code at a time.
And the book also mentions transactional memory.
Yeah, that's a way to make sure that changes to data are atomic. That means that they either happen all at once or they don't happen at all.
So there's no chance of two parts of your code interfering with each other.
Right.
Okay, so those are some good techniques for managing concurrency.
Yeah, and they can help to make our code much more reliable.
So now I want to talk about something that's not really technical,
Okay.
but it's still really important for software development.
What's that?
The human element.
Oh, yeah. The book talks about that too.
It does.
It says that software development is a human activity.
Right. We're not just robots writing code.
We're people working together to solve problems.
And that means we need to communicate with each other.
Yeah.
And collaborate.
And build trust.
Exactly. And the book gives us some advice on how to do all of those things.
Like what?
Well, it says that we should be open and honest with each other.
Okay.
And we should be willing to help each other out.
Uh-huh.
And we should celebrate each other's successes.
Those are all good things.
They are. And they can help to create a really positive and productive work environment.
Yeah, a place where people feel safe to take risks and try new things.
And that's really important for innovation.
It is.
So I think the main takeaway from this section is that pragmatic programming is not just about writing good code.
Right.
It's also about being a good teammate.
And a good communicator.
And a good human being.
Exactly.
All right, so I think we've covered pretty much everything from the pragmatic programmer.
We have.
It's been a really interesting deep dive.
It has.
What are your final thoughts?
Well, I think the book is a great resource for any developer.
No matter what their experience level.
Right. It's full of practical advice that you can use to write better code.
And to be a better developer.
Exactly.
So I would encourage everyone to check it out.
It's a classic for a reason.
Well, that's all the time we have for today.
Thanks for having me.
It was great talking to you.
You too.
And to all of our listeners out there.
Yeah.
Thanks for joining us on this deep dive into the pragmatic programmer.
Happy coding.
We'll see you next time.